Hello viewers, you are welcome to Bowman Maths class. In this video, we are asked to evaluate the integral of f prime of x over f of x dx. So we begin by saying solution. Now from here, we let u to be our denominator, or t, or any other alphabet. So our denominator here is f of x. So we let maybe u to be equals to f of x. And from here, we differentiate du over dx, differentiate u with respect to x. So we are going to have du over dx is the same thing as, if we differentiate f of x, of course, we are going to have f prime of x. And from there, we know that we have to make dx the subject because we have dx here. So make dx the subject here. So we are going to have dx is equals to du 1 over f prime of x. So now you substitute from there. Therefore, the integral of f prime of x over f of x dx, as given from the question, is the same thing as integral of f prime of x over our f of x. Now, this is f of x, and it is the same thing as f of x is the same thing as u. So now we have u. Then our dx is the same thing as du over f prime of x. So we have du over f prime of x. Now from there, f prime of x go with f prime of x. So we are going to have the integral, because f prime of x here 1, f prime of x here 1. So we are going to have 1 over u du. So we have 1 over u du. And according to standard integrals, when you are integrating 1 over x, it is going to be ln x. The same thing here, if you are integrating 1 over u, you are going to have ln u. So this is the same thing as ln u plus c, which is the same thing as ln our u is f of x. So we are going to have ln f of x plus a constant of integration c. From here, we can notice that whenever you are integrating a fraction, if the numerator is a derivative of the denominator, then your result will be ln of the denominator. For example, here, look at it. This f of x, we have f prime of x. So this one is a derivative of this. And we ended up getting ln of f of x. So whenever you are integrating, for example, if you are integrating sine x over cos x, maybe minus sine x over cos x. So now, if you look at it, if you differentiate cos, you are going to have minus sine. So you see, this one is a derivative of this. The numerator here is a derivative of the denominator. So you are, if applying this idea now, you are free now to take the ln of the denominator, which is ln cos x plus c. The same thing here, if you are integrating sec square x over tan x, you see, if you differentiate tan x, you are going to have sec square x. So this one is a derivative of this. So the same thing, if you apply, you are going to have ln of tan x, ln tan x plus c. The same thing here, if you differentiate exponential 2x, you are going to have 2 exponential 2x. So this one is a derivative of this. So now you are going to take the ln of exponential 2x plus c, and so on and so forth. Thank you.